while you're enjoying lunch. Thank you. I'd like to take this opportunity to introduce Valley from Google, who has recently undertaken an education program to try and bring more youth and energy into our industry. And he's done some really important things, so I'm going to give him a few minutes to talk about that and also share a short video which has looped a couple of times. Valley.
Thank you very much. Thank you very much. Can we start from the video?
This the slideshow.
The video.
This one?
Nothing can ever change.
And this thank you to all of you from students, and this thank you really to all lecturers, and this thank you first of all to Suboptic and Suboptic community. You saw we had fun. Elizabeth was running master class of beach volleyball, and Luncheon did World Cup, football, soccer World Cup. I did a running club, and 6:30 a.m. people show up, not many, but 6:30 a.m. And young people, they usually stay late, of course. So in between all those, we actually had 5 full days loaded with mechanical engineering, industrial engineering, oceanography, optics, nonlinear optics, government relationship, you name. Basically, our industry is really what we are doing in this room is a synergy of so many topics, and all of us have personal history, how we came to this industry. All of us know small piece, and basically suddenly in 5 days, we had pretty good view from top experts. Really appreciate Subcom, NSC, Alcatel Submarine representative, and top experts in the field committing their time, presenting lectures, and that was really important to have support of many people from this group. We started marketing this event exactly 1 year ago, and Chad and his team sent me first flyer that I was printing morning before lunch last year, and was distributing, if you remember, this flyer. And basically we had a strategy of kind of friend of the friend marketing, and many students came from this direction. And the second is CHATS and Optical Society of America, massive international network of talented students. Chat, if you could stand up. And thank you very much. Basically, we've got about 185 applications, and applications actually require quite a lot of work to basically do with reference letters. So we had very good applicants actually, and then 6-7 Googlers spent time and did analysis, and from this group we actually selected 100, and finally we've got 95 students in Finland in the middle of nowhere. So there was no way to escape. And all that you could do, just talk to your fellow students or to lecturers. And that was actually cool. And we actually all have got new friends. And the energy that we've got within this group, and some people could kind of support me probably, the energy in that group was enormous. It's difficult to imagine how interesting is what we are doing. You know, we are doing our daily kind of stuff, but when you bring this all together, for young people, they actually shoot questions. I was actually chairing all 5 days, and I think we had 1,000 questions plus during those 5 days, and this all actually could not be done without support of this community. So first of all, it's really Suboptic who sponsored us. Google and OSA basically founded and came with this idea, but the key was definitely support by Suboptic Executive Committee and support by this group of people. And we also had sponsors, and I will name Sienna and Nokia who supported us, and Cisco, and NMS Works, and Dimension Data, and Omantel, and DNA, and OFS, and OFS sponsored coffee breaks, and we had, every coffee break we had 2 different small cakes in Finland, and it was actually very, very tasty. And also Senior, the Submarine Finnish company, did a surprise stop by and really show a very nice video and welcome us in Finland. So I was a little bit kind of scared when we started all this, how these things will go, you know. It's all, whenever you do something first time, you know, you're always kind of high stress. And I had always thought that somebody will break a leg or something like this, but thanks God, we actually, everybody is healthy and in good shape. So my point, we actually decided to do the second time. And again, we are looking for your support. And again, Chat is here, and if you want to make material contribution, you could talk to Chat. He will be here next 2 days. And my great appreciation is to Eric, who basically let me introduce this school 1 year ago at this Luncheon. And we are looking to continue this kind of like tradition in future. Thank you very much.
With that, I'll introduce our next panel. I'd like to take just a moment. We talked about demand earlier, and Elaine talked about where it came from and how it came to be, and how insatiable it is that there are still 3.2 billion people in the world who are not connected. So there's more to it. And Eric is going to talk, and his panel is going to discuss how to manage that going forward. So without further ado, Eric, thanks so much.
Thank you very much. Good afternoon, everybody. Thanks for joining the Suboptic-sponsored lunchtime panel. I'd like to invite our panelists to come up, and while they do so, I also want to send a very personal thanks to Valley for actually having pushed the Summer Institute that we held forward, for having brought together people, and I think right at the core of what we do at Suboptic is building community and definitely focusing on education. Thanks. And so, big heartfelt thanks to Valley and everybody that supported him. Thank you very much.
Thank you.
So, what I wanted to do is set a little bit the stage. I think we're living in very exciting times, but it wasn't that long ago, about 150 years or so, when the first telegraph cable actually landed in Portcorno, UK. And it's incredible what has happened since. But if you fast forward to, let's say, some 3 to 5 years ago, and you see the changes that we've done from a technology perspective, if you look at what's happening in our lives, as you take a look at the fact that finally artificial intelligence is coming to life after maybe 50 years in development, when you think that the medical industry is going to be disrupted because people, let's say paraplegics, are going to be able to walk again through exoskeletons. When you think of the impact that autonomous vehicles are having, or brand new cities are being built as a smart city, where everything is connected to the grid, I think we're going to see phenomenal change in our lives. We're going to see a lot of new things happening. As Elaine said it, many things that we cannot imagine yet. But none of that is going to be possible if you don't have a robust global infrastructure that allows to communicate and use these technologies. And I'm very pleased to have a phenomenal panel here for you guys today. And what I'm going to ask the panelists just briefly introduce themselves so we can get on and start the discussion of our topic. So I'm going to start right here with you, Oliver, and then just kind of go down the line.
Thanks very much, Eric. My name's Oliver Jones. I'm the chief executive of a company called Chiora, Hong Kong headquartered, specifically focusing on being an investor, developer, and operator of world-class data center campuses in mainland China. China, we were just hearing about the headline in terms of 3.2 billion people not connected to the internet. But in China, there's already 850 million people connected, and it will go over 1 billion people online within the next 3 to 4 years. So we're focused on helping to try and bridge the opportunity that that digital behemoth presents to business opportunity around the rest of the world. We don't focus on any other market. We've worked very hard to be one of a very small handful of companies that hold telecoms licenses for IDC and ISP within the PRC. And from our perspective, being able to address the points that Eric talked about in terms of connectivity is vital. The final piece, and we'll say more about China a little bit later on, but in introduction terms, we've recently announced a strategic partnership with Telstra. Telstra is one of the other 5 companies that holds the same licenses as we do, to be able to pool our resources specifically around anticipating the opportunity that we hope will come with the trade agreement between China and the United States, in the hopefully months ahead. So from our side, we're a data center operator, hugely dependent on understanding telecommunications connectivity, and excited about how the global infrastructure network can be in place.
Thank you, Oliver.
Yeah, hi, I'm Paul Gabla. I'm VP Sales and Marketing for Alcatel Submarine Networks. We've been building submarine networks, optical infrastructure for decades, and submarine networks infrastructure at large for even more than that, many decades. And we are pushing and working hard on developing technologies that will allow to build a network that supports the very fast-growing demand that I guess everybody else will talk about too, and we are building the infrastructure that supports that.
Hi, I'm Shalini. I look after infrastructure sales for DXN Limited. DXN is a Australian public listed company that builds modular data centers. We focus on prefabricated modular data centers for ourselves. So we co-locate data centers. We have a data center that's located in Sydney Olympic Park. It's an edge data center. And we also build data centers for others on a turnkey basis. More specifically in the Pacific, we do cable landing stations, modular cable landing stations, and micro edge data centers in the region. We have our manufacturing facility in Perth in Australia. We have an engineering team who's also out of an Australian entity. We have sales, pre-sales out of Kuala Lumpur, Malaysia. We also have teams in Perth and Sydney. Overall, we have, as far as background is concerned, a lot of us in this industry have been in cable infrastructure and infrastructure to the edge. So as we go into modular data centers, we are starting to see a lot of interest in the Pacific, but also just greater Asia Pacific. When we talk about Southeast Asia and ASEAN regions, a big part of DXN's focus is also in that part of the world.
Thanks, Shalini.
Bevan Slattery, co-founder of Pipe Networks back in the day, built a submarine cable, hi Kent, from City to Guam, founder of NextTC, founder of Superloop, Megaport, CloudScene, Subpartners, built the Indigo system, and Subco, now building Perth to Oman.
Thank you.
Hi, my name is Kempe Fukuda. I'm the VP ICT Infrastructure Services for NTT. My main role or my responsibility is to create the global underlay network architecture for NTT. So NTT has a vast big network with a lot of data centers around the world, and my role is to make sure that all the data centers are located in the right places and have the necessary connectivities amongst the data centers and also the services that get on top of them.
Hello, my name is Yoshida from NEC, and I'm in charge of the Submarine network and also the microwave radio, completely different area from you. Actually, I have the big interest of this session and for future. However, currently, as of today, my biggest interest is the Olympic game in Tokyo this year. It's joking. But this is also very important for the submarine industry, I believe, because in Olympic game in Tokyo, 8K TV broadcasting also be introduced. It's a big data also transmitted over the world. So how impact to the submarine cables in future? It may be one of the interests for us. Thank you.
Well, thank you very much. As you can see, we have a great group of panelists here today. And what we tried to do is when we thought of the people that would join us in the panelists to see the different components and pieces of that global infrastructure. What is needed, not just the subsea piece, but how are things changing in the market and have changed over the last several years in the ways even in design and the architecture. What problems are we trying to solve? How are we trying to connect? And so I believe just from that perspective, getting started, let me start with you, Paul. Let's talk a little bit about the major changes that we have seen perhaps in the last 3 to 5 years in the subsea industry and what your outlook is, let's say, for the next 1 or 2. And then we'll basically go from there.
Okay, thanks, Eric. So indeed, we are living a time of big changes again. So this industry has seen a succession of really rapid evolution and sometimes a rather slow changes in the last 20, 30 years. So there has been the advent of optical fibers, then optical amplifiers. These were major revolutions, and then it was a bit quiet for almost 10 years, I would say. And now we are in a second surge in terms of market volumes for sure, but also about what technology can bring. So, of course, with the current detection technologies, transmitting equipment transmit-receive has become more and more smart and enabling higher capacities. But what we are seeing these days is the transmission technology is sort of reaching a plateau, and now all the submarine network suppliers are working hard on increasing, nevertheless, the bandwidth throughput of systems by multiplying the channels. So multiplying the number of fiber pairs and doing that, trying to do that more and more efficiently. And right now, if you just take a perspective of the last 10, 20 years, so the capacity that the submarine network can support today is more than 1,000 times what it was 20 years ago. All at the same time, the price of that has been divided by about 2. So you can see that capacity has never been as affordable. And what is really fueling demand these days is the demand of new applications. The 5G that's going to be deployed in most countries will create enormous demand from end users, and therefore the underlying infrastructure that we're building has to be able to support that. And right now, if I try to look at where it's going in the next couple of years, we are working hard on continuing to increase the capacity of a single submarine cable, at the same time developing approaches that allow to have efficient redundancy between the various physical routes that the systems are taking, so that the network is completely fail-proof. And given the traffic demand that we see these days, we see this trend continuing to increase over the next couple of years at least. And beyond that, anybody has to have a crystal ball. But at least for the next, let's say, 2 to 4 years, we think growth is still quite steady for us, suppliers. It means that we have to gear up, not only on the technology, but also on the capacity to build and install more systems at a faster pace than we have done before.
But one of the things that I have seen is also the way that these systems are built. I mean, the majority of them are being, let's say, funded to some extent, the big, massive trans-Pacific ones, let's say by the OTTs who have this insatiable desire for data. We're predicting that future, how much you need is very difficult. But what they're trying to do is they're trying to make sure that to some extent that connection between data centers becomes just like a cross-connect inside of the facility. So having that connectivity is important. How are you seeing the change in architecture? What's happening to the landing station? What's happening to the data center itself as we try to build these huge bridges across continents?
Yeah, so what has changed indeed in the last couple of years is that we are no longer building to the beaches. We are really building straight to the POPs or data centers, which are not necessarily close to the beach. So that means that there is a quite significant portion of terrestrial route that is actually integrated optically into the overall network. So that's a major change. Apart from that, these global customers really want to manage their whole network as a single thing. So which means that the terrestrial infrastructure and submarine infrastructure needs to be managed by the same network management software, and that's also a significant change. So the frontier between terrestrial networks and submarine networks and between terrestrial suppliers and submarine suppliers is getting more fuzzy these days.
Shalini, what do you see? I mean, you built some of that infrastructure.
Yeah, exactly what Paul's been explaining about how the multiplexes are now moving into the point of presence. So we built cable landing stations. Typically in the Pacific, you still have SLTE racks installed within the cable landing station. But as you have more and more capacity and the demand for the global internet companies building up into and having an expectation of a seamless network right up to the POP, we're starting to see the SLTE demand and the installation of that termination of the multiplexing happening now closer to the point of presence. Now, what's interesting from our point of view is that obviously we build edge data centers, and we're talking about anything between 200 kilowatt up to 2 megawatt. We're starting to see an interesting phenomenon where while our cable landing stations have typically had SLT racks and PFE racks, which is the power feeds, it's starting to be more simplified in terms of design. Cable landing stations are just being a transparent channel. And whereas our edge data centers, where the capacity and the compute power there is an expectation from a demand point of view, to carry a lot more compute power for better latency. You're starting to see, all the multiplexing from companies like Alcatel-Lucent being installed there. So definitely there is a huge architectural change, and from our point of view, it's a huge opportunity for us, because that means that we are starting to see the edge play, or the edge data center play, as opposed to the complexity in the cable landing station and terminating against a terrestrial network.
Yeah, so you're aiding to some extent, or you're seeing a shift, let's say, in your market. And again, I think connectivity is absolutely critical, right? And I think, Oliver, you started to mention some of that. And what are you doing, let's say, at Chayura? Because you're like in the largest nation in the world, right, with a huge amount of growth. I think when we think big, in Latin America, you think 10 megawatts, 20 megawatts. Your campus alone is 300, but yet it needs to be connected.
Yes, one of the biggest challenges in dealing with China is to move from thinking hyperscale to thinking China scale, which is a little bit bigger. And when we first started looking at what a scalable campus needed to be, and we came up with a modular scale of circa 300 megawatts of gross power, for many people that was, just something that wouldn't be conceived in many parts of the West. But China, represents, as everybody knows, 20% of the world's population. But it's only when you break it down, and perhaps if I may, just to sort of illustrate that, China's 1.4 billion is best understood by looking at it in summing a number of other countries. So all of North America, plus all of the European Union, plus all of the former USSR, plus 10%. That's 1.4 billion people. And so as a market, what we've seen is that the scale that we're operating to, a number of other hyperscale data center developments are taking place within China, principally focused on the domestic market, where huge growth is taking place. Companies like ByteDance, that most of you will be familiar with now as the owners of TikTok as an online app, deployed 30,000 racks over the last 3 years, and that's enormous scale. So our campus alone on the edge of Beijing is for 25,000 racks or so, to place that in context. So to the point in terms of connectivity, the other big challenge in China is that, of course, carrier neutral often means having perhaps 2 or 3 carriers coming into the location. And the challenge of working with the very great capabilities of the CU, CT, and CM, the 3 big telcos in China, who have incredible skills and incredible global ambition. That needs to be matched by a way that we can enable customers of ours to get confident that they can not only have commercially compelling solutions on network connectivity side, but absolutely huge bandwidth capabilities. And we see the need for bandwidth and connectivity to grow and grow and grow at the present stage. You mentioned a point about artificial intelligence and investment in that area. Now, China is setting out its stall to be the world leader in artificial intelligence by 2030. And that's an easy throwaway comment, but of course, unlike many nations, China's government will set out a plan which will be all about ensuring that that happens, and a series of 5-year plans, as you're aware. And so we find ourselves working with a province called Tianjin on the edge of Beijing. Tianjin, incidentally, where it's anticipated a new Chinese-led landing station will be, christened perhaps in the next couple of years once government approval has been achieved in that location. But in Tianjin, the commitment that they've made in investment terms is huge. $16 billion committed to AI and machine learning R&D at the government level. And again, compared to Europe, that's more than 5 times that all of the European governments have committed to that space. So for us, we start by thinking 300 megawatts is quite big. We start by thinking that connectivity needs to be omnipresent. But actually, I suspect we're going to have to recalibrate all of our expectations and, anticipate 10 years' time in the infrastructure that we're putting in today. And that's really where we have the biggest challenges, and that's why being able to enable international companies to get backhaul back to the locations where they're based outside China, and doing that in a way that works with the Chinese regulations, but also to international expectations, is the biggest challenge we now face.
Wow, those are massive numbers. I wish we would have a fraction of those. But yes, definitely big challenges. But that also opens up opportunities, right? I think that's where entrepreneurs can step in, and you want to sidestep, let's say, some of that linear thinking to take advantage of the exponential growth. So Bevan, you've been, or are, Australia's probably most successful entrepreneur. You've dabbed in different areas of the infrastructure ecosystem. How do you see this? What are you looking at? How important for you is that connectivity, that interconnection, perhaps reaching, let's say, new markets in your neck of the woods?
Yeah, certainly if I put the submarine cable hat on, I think the thing that we're seeing now is what you'd call, and it'll probably be the name of the next year's panel session, it's hyperscale cables. So what you've seen happen in the data center space, which is hyperscale, the hyperscalers have come in and done the data center space. They're going to now come in and do the submarine cable space. So, and I believe it'll happen very similarly to what happened in the data center space, where the routes or in the data center space, the markets that are hyperscaled first will be the major markets, the major routes, and then it'll kind of make its way through to tier 2, tier 3 routes or tier 3 markets in the data center space. What happened there? How did that happen, and what was the thesis behind it? The thesis behind it was, we need to build scale. With scale comes economies of scale in terms of both CapEx and OpEx, and we can kind of leverage that for the somewhat benefit of the industry, but certainly themselves. They kind of and you're seeing infrastructure investors kind of coming into that market, and that market's probably getting a bit frothy, I'd say, at the moment for some players, but one of my companies, may have some advantage of that. So really from my side, I think cable's going to get cloudified, and hyperscale, I'm saying you're seeing 16-pair systems, 32-pair systems being muted out there. And why does it matter? It means everyone gets their own fibre pair. They can put their own equipment on the ends of it. Instead of being a 100 gig owner of a 2-pair system in the old days, and that was your economic return, they're taking a 1/16th capital cost of a cable, 1/16th operating cost of the cable, are running 20 terabits over it, which is probably enough capacity they're doing. And they're just going to do that continually more and more on those routes, and all power to them. It's going to be, Paul Gabler's going to be cheering them on, and so is NEC, and so is Subcom. I think they're going to have the busiest 3 years ahead of them right now. They're going to be drinking from a fire hose. From a connectivity standpoint, I think, and we're seeing it, right? So they're taking the efficient route, they're taking it straight to the data centre, where there's a data centre or an interconnection point, a meaningful interconnection point close to where traditionally you have a landing station. They're taking that out, they're disintermediating. There's no value in being in a landing station unless it's a long hop to a major interconnection route. I shouldn't say no value, there's less value. They're taking it straight in. That way you have one set of optical equipment, you have lower remote hands, or in a location with good remote hands, or in a location where there's no latency added necessarily between the submarine and optical, submarine and terrestrial. And I think, again, that kind of, and you're seeing this happen in the equipment vendor side, Sienna, Infinera, whatever it's going to be, it's also being hyperscaled. There used to be, Subcom, great guys, used to have a fantastic line of submarine cable equipment that they used to terminate, their SLTE. That disappeared, probably 5, 6, 7 years ago. They're using, I think, Sienna now. Basically you're seeing the terrestrial equipment and the submarine equipment's the same thing. The interconnection points are the same places. The hands that'll manage them are the same people. So basically my kind of simple theory is that submarine cables will go the same way as data centres, and they're going to get hyperscaled.
I think what's interesting there in what you present is that obviously things are changing quite rapidly, right? And so not only do we have to think about what's next, we have things like, how do you sidestep the Shannon limit? We have a working group at Suboptic that's doing that. How do we pump in more capacity? There's even a startup company being funded in Silicon Valley that's looking at potentially building optical fiber in space so that they don't have the effects of gravity. They can do a much better, cleaner, pure glass, and therefore increase the amount of capacity. So it's all about, let's say, addressing that. But I do also believe that the points of interconnection are critical, and how those are managed are important. The fact that you're laying new cables into new geographies, into new areas, because you need the diversity, is opening up the possibility for having large internet exchanges. We saw it, for example, in our case in Brazil. Fortaleza used to be just a landing site of many cables, but if you enable it, if you bring people together, if you create a community of neutral access, all of a sudden people do start to interconnect because the need is there, right? So you just have to make it easy, right? And I do believe that there's going to be tools that are going to allow us to do that better, and better. Things like SD-WAN, et cetera, that are being deployed where you can remotely enable, let's say, that communication and that interconnection to create true, let's say, matrix-type networks.
A bit like Megaport.
What's that?
A bit like Megaport.
Yep.
Exactly.
So what are you seeing, or what is, let's say, NEC or NTT working on to make that easy, to make those connections reliable? What are things that you're working on in this space?
From what I believe is that I started to see more of like what our customers really need is. So when we look at our retail or our consumer customers, so mainly the enterprises especially, all they want to do is connect to the cloud in the most, efficient way and most reliable way and also most secure way. So in order to make this happen, I think one of the things we really need to do is make sure that we have a reliable, very reliable network. And I think Eric just mentioned about SD-WAN, but SD-WAN is an overlay which nobody can control. They just control the over-the-top routing. So what NTT is trying to do actually is try to make sure that we have an interface to actually control the underlay as well. So, which means that when the customer needs to have a, for example, a very short latency application that is on the network, then we will probably have some kind of API to understand the application and give them the shortest route possible, for example. And also another thing is that we've been doing a lot of exchange fabrics, the switch fabric, where I think Megaport had been doing a great job. Of course, Equinix had been doing this from 1999, I believe, when they first started. I think when we see this evolution, everything started from interconnecting the racks inside the data center. And they started to have internet service providers. So they started to interconnect those, and that became the internet exchange. And then a few years later, Ethernet became a boom, and then so the Ethernet providers connected to the switch fabric, and that became the Ethernet exchange. And now it's the cloud exchange. So I think in the future, we may probably need something like a subsea cable internet exchange, where we see a lot of routes, but not to different locations, but probably the same path, but with more, not needing to have the real ownership and things, or even having real, it doesn't have to be the fiber owner, or you don't need to buy the real capacity, but maybe we can sort of like to use when needed, kind of, architecture. Maybe that can be something that is needed to ensure that we have the right, secure and reliable connectivity for the customers.
I think that notion of capacity by the drink is an interesting one, right? But at the end of the day, building these infrastructures is very costly. So who's going to pay for it? How are you going to make that model work if you have to lay out millions of dollars first to then make it easy to interconnect and you just pay for usage? Anybody, I mean, we don't have to go down the road, but what are your thoughts on it?
But I think, so looking back 10, 12 years ago, So I started to come to PTC back in probably 2009 was my first time. And when I came, it was, so I had to see Bevan he needed to sell me capacity from Guam to Singapore, Sydney, for example. And I remember I was selling capacity to the hyperscalers, the cloud players. So Google was one, Facebook was one, Amazon was one, Microsoft was one as well. But like you started to see, they started to own their own fiber, or they are the ones who started to take the initiative to build fibers on the subsea. So I think that once that gets down the road, we will have more like excess capacity that can be hopefully traded like on the exchange, for example. So we carriers probably will own like small capacity from each of the fiber systems. Maybe the carriers can form a consortium or an ecosystem to actually have a switching point to interconnect with each other, and we can trade capacity. I think that can be something interesting. And we can charge by minutes, like we did in the old IDD calls, maybe.
Yeah, it's funny on that point. I mean, when I started Megaport, a couple of really interesting points about that exact one. It was all about, it doesn't really matter your location. You're on a metro fabric, and you get a port from us, and you can buy and sell a service from any other service provider or anyone else who's on that network. And it's taken longer than I probably expected for the carriers to automate buying and selling services to each other. They're still fairly old school. You know, we still send out emails and RFPs and make phone calls. We still come to Hawaii and do this stuff. You know, but that is coming. I think that point. And to answer your question about, you know, and look, if you want to know the future of that, just cloud seeding. But when you kind of combine a Megaport, which is a fabric that interconnects at the metro level, and there's other providers around that do that. The other part is the marketplace or trading platform that allows people to do that, and certainly that's probably where my head is in the future. But to answer the question about who's going to fund that and pay for that, I mean, I think it's already being done, and it's already being done by the clouds. And you'll start seeing their product portfolio come out. You know, you're seeing Global Transit from AWS. You're seeing similar product from Microsoft Azure. You're going to see the same thing from Google. And to the point that was made by Kempe was that, you know, you're going to SD-WAN is going to throw on top of this, and people are going to spin up if it's Velo Cloud, they're going to spin up a Velo gateway in compute instance in whatever region they want to terminate their IP locally, to make the routing more better and connect to an IX. That investment's already being made both at the compute level, at the capability platform level, and I think at the network level. And I think we're going to start seeing that happen more and more from the cloud providers.
Can you comment, share some?
Yeah. I just would like to mention the different view, especially in the 5G. Currently, either Korea or China already started the 5G, and in Japan also this year, we will start the 5G. 5G does not impact the submarine. Everybody thinks so right now. However, how 5G will be used. Actually, it's not just the people's communication, but I believe its main purpose is the machine-to-machine or device-to-device. In that cases, for example, Google already developed the automated car, and everybody say like connected car. Those kind of industry needs the tremendous data traffic. And 5G can achieve those kind of services. Once those kind of services is started, I believe the international connectivity is more important than before. And in that cases, not only just the GAFA or data center company, but also many of the service company wants to use the submarine, not only submarine, but all of the global network. So maybe, of course, the NEC is a manufacturer and the system integrator, either from the NEC's viewpoint or operator's viewpoint, or even either the data center company's viewpoint. Maybe we have to provide the more different services. How to generate those kind of services, it's one of the key for us, I believe.
But that also requires you to start pushing a lot of the compute power to the edge. And so the entire infrastructure, whether it's data center edge computing, whether it's a terrestrial network or subsea, is just growing, right? And you're just pushing certain things out. That traffic that is local, let's say in the case of an autonomous vehicle, is probably going to stay within a certain reach, or those things that are IoT are going to be within a certain reach. But how do you see the growth of that traffic and taking that data back, let's say from the edge perhaps to a more central processing data center site? What are you saying?
Well, perhaps picking up on the point about autonomous vehicles and the nature of the capture of data associated with autonomous vehicles, one has to start, in my view, moving away from thinking about it as a particular specific application and a specific industry aspect. Each autonomous vehicle is going to generate huge amounts of data, circa 3 to 5 terabytes of data per hour for each car driving. And you imagine that when you multiply that by a number of hundreds of millions of vehicles, for example, in China. One of the big challenges, of course, is that when people think about autonomous vehicles and the data being stored at the edge, the assumption is that when you've managed to go around a corner and not knock over or kill a pedestrian, you don't need the data that got you around that corner. I kind of beg to differ on that. I think that the lawyers of the world will insist that 100% of all data, at least in the first few years, is retained. And when you start to think about transmitting that data, you can't send 4 terabytes of data comfortably over probably even 5G very effectively. So it tends to be associated with electric vehicles where you can download the data and you can hold it locally. But the interesting piece for me is that actually if you're going to hold on to 100% of the data that's been captured, you start to change society. And China's view of this, I think, is really interesting. Very different from the view that many of us would hold in the West about surveillance and people knowing what's going on. In China, the opportunity to use surveillance to just make cities work in a different way and security work in a different way. And you start to think about driverless cars as perhaps being the eyes and potentially even the ears of the city to understand what's going on. The prospect of being mugged on a street in Beijing in broad daylight with the many CCTV cameras that are around and the driverless cars means that actually levels of crime will start to drop. And if you start looking at the insurance industry, for example, with driverless cars and data being captured, I suspect that the car insurance industry will perhaps disappear because contested claims will be captured on not just virtual reality, but a recording of actual reality taking place. So the interesting thing for me is that when we start to think about massive new innovations like autonomous vehicles, one starts to think initially about saving 1 or 2% of the data, but then the data, as we've learned in retail, as we've learned in so many other areas, that's going to be the ultimate valuable commodity that comes out of it. And those who hold that data and those who are able to mine that data and interrogate that data will be the people that make the real fortunes going forward from here. So I think that we're enabling, as an industry, through both connectivity and storage, the ability to do something quite transformational, I think, in the next 10 years in that space. So perhaps that's a broader way of thinking about it.
And you just reminded me of something. There's Mercedes-Benz in Germany. They're looking at how we're going to use end-user data coming from their cars.
Yeah.
And as a matter of fact, they decided to totally redesign their network. They redesigned where they want to have their data centers. They're looking at when you get into one of their cars, they don't want to have Hi Alexa or Hi Siri. They want to have Hello Mercedes. And then they want to be able to capture that data and potentially sell it, right? So the initial idea is I'm going to use that data from the end user and from the vehicle to know what's going on inside of the car. But while we have our microphones and cameras, whenever they're capturing all this stuff, and it's 12 o'clock, you're hungry, and they know that last time you ordered a steak, and here's a steakhouse 5 minutes away. Mm-hmm. Let me do the reservations for you, right? So in order for all that stuff to happen, that data needs to be stored. It needs to be fast. It needs to be accessible. So I do believe that that's a space where we're going to see phenomenal amounts of change. And the way that some of these large companies are looking at it, initially is they would buy services, let's say, from a carrier, and now they're saying, wait a minute, you know, if we have all these cables across the Atlantic, or maybe from Europe to Latin America, we may want to have our own fiber pair so we can control our own infrastructure to be able to monetize it in a different way. So those are very interesting changes that we're starting to see, let's say, happen. I'm not sure what it's going to lead to, but that you just reminded me of that as something that the creativity that we're going to be faced with. There's going to be people coming up with all sorts of ideas to be able to monetize, let's say, and use that infrastructure. I don't know what you guys see in other parts of Asia or the Pacific, but our world is definitely changing in that direction.
Yeah. So in terms of the evolution of technology, what you're mentioning is interesting for us, because indeed the network, the way to design network and architecture network is going to evolve, because, as you said, a lot of data is generated locally, probably stored locally or processed locally, and that means that the current architecture, where everything is transmitted across the oceans and replicated everywhere, is probably going to evolve a bit, with more and more local networks being developed and data not necessarily crossing the oceans all the time. So it may change the architecture and actually push to develop more regional system than big pipes. The big pipes, of course, we'll still need them, but there may be some changes coming in the next few years. Another interesting point that I heard before is about the granularity of networks. So before, in the last couple of years, all the suppliers have worked hard on developing switching devices, optical switching devices that switch wavelengths all over the place. And now, with the advent of high fiber count systems, we are seeing a new trend developing, is that the granularity unit is the fiber itself, or fiber pair. So which means that, as you said, fiber pairs are becoming more and more affordable with high fiber count systems, and then customers are buying full fiber pairs as opposed to just a few wavelengths. So the suppliers are seeing a trend coming from our customers, that they want fiber switching devices rather than wavelength switching devices. So that's, I think, something that has really changed the overall architecture of networks.
And I think one thing that was mentioned in the previous panel as well is, you know, having branching units and systems, or accessing, let's say, remote islands, or accessing, let's say, emerging markets. Because if you don't do that, they're going to be that digital divides and will get even bigger, right? How is that being addressed in your region?
In which region?
Yes, so this is specifically in Asia. So the Asia-Pacific market is a huge market for us specifically. And if you look at the growth that's coming into that part of the world, predominantly data centers have been installed in Singapore, Hong Kong, Japan. This has been the hyperscale market as far as the last 5 to 10 years. What we're starting to see is that the internet companies that is driving a lot of this growth is now looking at the greater Asia-Pacific region, and I'm talking about Jakarta, Metro Manila, Ho Chi Minh City, Bangkok, and these sort of regional, as far as they're concerned, smaller cities relative to the hyperscale builds that they've been building in Japan, Hong Kong, and Singapore. And what's happening is there is a huge need for that infrastructure change, and that infrastructure need in pushing data out to the customers, ensuring geographical redundancy, and also a lot of these countries are expecting that data centers are going to be built within this region. So what we start to see is companies like us, we are starting to see a lot of conversations. Now what's going to happen in the next 12 months and 24 months is yet to be seen, but we're starting to have these type of conversations where, you know, you might start at a cable landing station within a regional city, which then grows into a edge data center, which effectively brings that architecture and that data to these cities. And we have many different examples of the internet companies doing this in Jakarta, for instance. Likewise, you're going to start seeing this in smaller cities. When I say smaller cities, I'm just talking relative to, you know, the big hyperscale builds that has been happening in Singapore, Japan, and Hong Kong. Particularly where we're concerned, the edge market is where this is, and the internet companies certainly are looking at having their own data centers and facility and data termination within that market.
That's the sort of demand that we're starting to see now, I would say in the last 6 to 12 months, and we're going to start seeing this architectural change over the next 12, 24 months.
I mean, yeah, I think at the end of the day, what's going to win the game is platforms, and you know, it's platforms win. And you know, if you go back, you know, 20 years ago, it was you know, hardware, and then it was virtualization, then software as a service, and I think ultimately platforms win, whether it's an API integrated software platform like Salesforce and whatever it might be. But I do think the main race, is certainly the big race in which platforms are going to be the leading platforms, is kind of already finished its first event, which is the major cloud providers. You're seeing some challenges come through. Equinix's announcement that they acquired Packet to get into the bare metal space is more evidence of that. Because I think at the end of the day, if you're an autonomous vehicle manufacturer, you're typically not going to go out, and people are going to start focusing on what they're good at. So if I'm good at building autonomous vehicles, you know, am I going to build a global network to support that, versus am I just going to, you know, try to arbitrage or work with existing cloud providers that do the compute engine, the edge, you know, pushing out to the edge of the microservice, or the interconnection in the metro, then the long haul, then the global. I think they're going to use that. Obviously, the major providers that already have that platform have an advantage to go into some of those markets. But from a cloud services standpoint, you know, I don't think we can underestimate the power and influence and the scale that these platforms have built to make the consumption of compute to deliver the great outcome that your business is on, whether it's SpaceX or Uber for vehicles or whatever it might be. A lot of those have been built on using the compute for where, you know, leveraging that network and infrastructure investment spend, because that's not their business. Their business is delivering a better service to their end customer. So, you know, I think there'll be some challenges to it, but I do think that the first round of the main race is kind of run, and there's more to come, and there'll be more challenges. I think you're going to see, you know, the real step out that we were talking about before of, you know, Alibaba, Tencent, you know, get further and further out in the market. Obviously, they're probably focused very much on China, but they're going to try to get out, not so much probably in the US, but, you know, CMI, CT, CU, particularly CMI, are going to help lead that investment further out there and be their champion for them globally. So I think there's another kind of people that are going to become running along and racing. But as I said, you're seeing Equinix now get into Packet, which is again about trying to provide a compute edge further and further out in the market. So I think it's going to be an interesting kind of space in the next few years. But I personally don't necessarily think that if someone's looking at doing a certain thing, that they're going to build an entire global compute platform to deliver that product, because that's going to take up so many brain cycles of smart people that they're better off focusing on the problem they're trying to solve.
You just open up another huge crevice when it comes to brainware, right? Brainware. We discussed this a little bit yesterday, so I'm going to go down that tangent a little bit. And we asked the question, I think Amy asked the question here in the panel, is how many people are in the audience that are, let's say, younger than 35? I don't see any hands coming up. 1, 2, 0? All right, thank you. So it's going to be critically important for us, and not only in the subsea space, in the data center space, et cetera, to make it sexy again, to attract talent to come into our industries, to address exactly those very challenging issues, to give us a different perspective. Obviously, summer schools, they're great, education is great, but what are you guys seeing? How are you attracting that talent? How are you looking for that next generation of brainware to come into our businesses? Well,
perhaps if I can kick off on that, one of the bigger challenges in the global data center world is being able to attract and motivate talent, exactly, Eric, as you've just said. The difficulty is that at the university and at the training level, actually the programs reflect many of the granular traditional engineering skills as opposed to a systemic approach or an integrated approach to applied engineering. And I participate as a director of an organization called Infrastructure Masons, iMasons, which has been put together by, actually the founder is Dean Nelson, who's sitting at the back over there, formerly head of compute at Uber. And one of the goals that we've set out to achieve through iMasons is to be able to start providing very clear direction back to leading universities on what programs need to be run in order to fill what might be 50 to 100,000 in the US gaps in the specialty employment chain, and many times that on a global basis. Because I think there is a problem with attracting people into digital infrastructure and enabling that to make a massive difference going forward. And unless collectively we're working across companies and with government and with educational establishments, I think we've got a very, very big problem, which is not going to be solved just by great engineering and great hardware out there, because the peopleware factor is going to be what lets the whole system down. So I think it's very, very important on that front to be able to also embrace, for example, the sub-optic community, to be able to engage with the data center world as well, because we have very many of the same requirements, and we've got to be able to drive that in all locations. Final bit I'd add to that, one of the features we put in place in China was to make sure that we set up a relationship with a leading technical university, in order that when our customers come in and they don't want to bring expatriate skills all around the world, it's non-sustainable and it's the wrong solution. But setting up as part of the whole package is not just about a physical environment that can be great, but a community and resourcing environment that can be well supported. And having that as part of the solution, so private sector working with public sector, which is very common in China, but doing that in other markets is a really important part of trying to address that gap.
Oh, excellent. How about you guys, please?
Yeah. I think there's two big different market. One market is the, as we are now positioning, big demand or big data traffic between Asia and America, or Europe to America. Those kind of the continental traffic is very huge one. But on the other hand, the same as the previous sessions, small island demand is also not big one, but required, and the fundamental infrastructure, maybe it should be promoted by either government or a private company or other company, but this is necessary. And how to implement this area is also one of the key. Why? For example, just example, in Japan, one of the small island, the people is just the less than 100. Those small island, there are many small island, and we are trying in Japan how to deliver in that island. Of course, as you know, there's no supermarket, no hospital. So how to deliver the food or medicines or any necessary goods? So we try to use drone. And drone can be delivered. The next issue is how to control the drone. Because they are 10 kilometers far from the main island. Then one of the Japanese airline company also tried to control those kind of drone from Tokyo, 1,000 kilometers far from the island. How to do it? So we need the big network. Big means not the big capacity, but the long distance network. And the microwave or the LTE cannot deliver those kind of the 1,000 kilometers. So fiber network is almost necessary. And those kind of the infrastructure, submarine cables infrastructure is also one of the key for the smart city for future. So of course, monetize matter is an issue, but we have to think about, this industry have to think about how to generate those kind of the new market as an infrastructure.
Yeah. I cannot concur more than what you say. In fact, I was thinking while we were talking about hyperscale and stuff, I was thinking, yeah, well, there's another side of the market, which is, I don't know, maybe I call that microscale or whatever. But systems that we install are really big pipes across the ocean, as Naoki said. But on the other hand, we are also installing systems to serve small communities. And in that case, they don't need like 16 fiber pairs at I don't know how many terabits. They just did one fiber pair with a couple 100 gigabit, because that is already like 100 times or 1,000 times more than what they get today by satellite. So, for example, we have installed systems in the South Pacific, which are now bringing all these new services to small communities. Just as Yoshida-san said, a few hundred people on some atolls or some islands, but if they have just one fiber pair with just 2 or 3 channels, for them it's a sea of change. And they can join the digital economy or digital whatever that right now they cannot access.
I mean, the only caveat I'd put to that is, shouldn't say to that, but generally, you know, look in the sky, not just under the water, I think, when you understand the scale of what they're building at SpaceX in terms of their constellation. You know, if as a submarine cable industry we don't solve that problem economically for the islands, someone else is going to solve it in the next 5 years. I still think there's a great opportunity because there's nothing better than low latency, highly reliable submarine cable capacity. But you know, the idea of having protection and diversity through satellite, and sometimes that business case for some of those smaller islands to get some of that satellite service will happen pretty quickly, I'd say. But again, as we've known in this industry, we think you hit like Bill Gates said, 640K amount of RAM is all you'll ever need. You know, I think we've all said the same thing about bandwidth at some point in our time. You know, and as we've now passed, I think 2 years ago, we now have more connected devices in the world than people, and that's going to only increase by a factor of 2 or 3 over the next number of years. I'm not saying Pacific Island submarine cables aren't going to happen, but I think fortunately there will be a pickup in capacity and opportunity in those islands that submarine cables can certainly either help lead or follow later once they get that kind of pickup in that industry or whatever it might be, and we support. But if you're building business plans and spreadsheets, keep an eye on SpaceX.
Yeah, the additional point is that, in fact, that's the bottom line. It's not a business case in those cases. It's sort of public service. Yeah, and that's why it's funded by some governments. New Zealand is very active in that respect, for example. And it's not a business case.
French, yeah.
Yeah, French too, yeah. So there is no business case because it's just...
you need to come and talk to our government for a while.
Very, very, very good. I mean, it's you know, we have representatives here from different industries on the panel, and you see that there's a commonality of topics, right? The fact that technology is changing very, very fast, the fact that we need that technology to close the digital divide, the fact that we need people, and we need to attract newer people to the industry. And I think, Oliver, what you mentioned is absolutely critical. We at Suboptic, we've always had a phenomenal technical community. And we've been able to share data openly. We've been an entity that likes to add, to integrate, et cetera. And we need to go outside of that space. We need to be close to the data center community, have the same issues. And we need to address some of the regional requirements that we were talking about before. So now it's not about necessarily only let me lay the cable or let me build the edge data center, but looking at how some of these pieces work together. Drones, for example, for little islands. I hadn't thought about that. I think that that's a great example of how you can use emerging technology. What I will tell you is that 10 years ago, there was a huge business of cameramen flying helicopters who take all sorts of different shots of buildings, angles, whatever. That business disappeared. And it's only today, it's done exclusively by drones with a guy that sits there, ideally a kid that learned to play video games, and is very comfortable with flying these machines off of the screen. So I think we will continue to see that innovation. And talking about that innovation, we have a few minutes left. Japan this year, big Summer Olympics. I believe they're after, 2 years thereafter is the Winter Olympics. And we lived some of that in Brazil when we did the 2014 World Cup, then the 2016 Olympics. there is a huge amount of investment to build that infrastructure to be able to deliver those games, right? So how are you seeing this? What is being done?
Just to complete the picture on there, so obviously the Tokyo Games next, or this summer now, of
This
course.
summer.
Beijing is then hosting the Winter Olympics in 2022, and often it is when you get such global showpieces that it incentivizes countries to demonstrate their capability to the world. What's very interesting at the moment is not only is China doing what China does very well, which is creating incredible infrastructure and high-speed rails and new airports and a whole new zone that is around the ski resorts, which are to the northwest of Beijing. But China Unicom recently announced, because they're leading the televisual broadcasting, and they want to use it as a means of showcasing 5G for everybody. And one of the things that really inspired me on that front is that they set out a goal that wants to make participation in the Winter Olympics a virtual reality for the audiences around the world. So the ability to, be the downhill ski racer, to be the skeleton racer, to be on the wagon or on the skis, and have your own means of looking around that. Now, when you start to see that type of innovation, and China's very, very good, as we remember from 2008 Olympics, at using it as a means of just reminding the world that they're doing some clever stuff out there. But I do think big sporting spectacles like that will shift the needle, will suddenly leap forward in the same way as other global events take place. So I'm really excited to see what they do. How that applies to what we can do to support it and the international connect, I've got no idea, if I'm really honest. But I just know that the kind of step change in innovation and the stuff that Mark Zuckerberg talked about in terms of being able to fully experience somebody else's world, and the fact you can't go to that party, instead of just reading about it on Facebook, you can actually be there in some virtual sense. I think we'll see in 2022 a massive step forward in that area in terms of sports participation, at least. So, exciting stuff.
Yes, as I mentioned beginning, yes, this year is most important for Japan because the Olympic Games will be held. NEC is also, NTT as well, but NEC also one of the sponsors of the Olympic Game. So we are very excited. Actually, NEC provide a security solution, including the face recognition, for protection of the terrorism. And also any of the site, as I mentioned, 5G and also the 8K broadcasting also will be introduced. And those kind of the solution will be delivered over the world. So of course, this is one of the demand for the submarine cables and also international network. But not only that. Another issue is the tourist. We understand many of the tourists comes to Japan this summer, and especially in Tokyo. So, and the hotel and also the many of the sightseeing place also we already prepared. The problem is maybe network. I don't know how many people comes to Tokyo, but how we can satisfy those kind of the people to use either internet or any data traffic. So I'm not sure the remaining timing is only 6 months. So I don't think we can prepare everything. But anyway, I think this is one of the case, not only just the Tokyo Olympic Game, but for future. And also, maybe not this year or not next Olympic Game, but sooner or later, e-games also will be one of the topics. In that cases, I don't know how many people wants to see or join through the internet for this e-games.
Just for Kudai-san, I'm going to be at the Olympics this year in Japan, in Tokyo. Not as a competitor. That might surprise a few. Might give the old Greco-Roman wrestling a go. One of the things I'm most excited about is I went to CES last week, the week before, and I was interested in drones. I was interested in home automation, and I have to say, surely, you have to give me something to be excited about. I'm going to give you some statistics on how good this network is, because I'm sure I'm going to be sitting there taking plenty of video, plenty of content, sharing it back to Australia and FaceTiming with family. What have you got going there? What's going to get me excited? And is this Apple 11, is this a 5G phone or is it a 4G thing? I don't know, I haven't followed up. What should I use? What should I do? What should I experience? What are you going to give me?
Wow,
How much bandwidth?
endless. So actually, NTT is a gold sponsor for the Olympic Games for Tokyo 2020, and we've been preparing for the Olympics since right after the Rio Olympic Games. So we've been preparing for this for the past 3+ years, and what we're doing is we are making sure that we have enough fiber around the stadium and the data centers where the stadium, data center, and the press conference rooms, so that we don't see any congestion, and we make sure that from the press conference rooms, all the video will be actually sent to all over the world. So for the global network, the subsea cable is very important. It's not only NTT, KDDI is also participating mainly for international broadcast. And I believe that all of that, plus like we've been trying a lot of, initiatives in the stadiums as well, trying to give good connectivity, Wi-Fi connectivity inside the stadium, so that the people who's watching at the stadium, it's not just watching the game itself, but through their smartphones or the iPads or whatever, they can see the real, the scene of where they were really impressed, for example, or they can just keep on sending blogs and messages to their friends inside the stadium, or even from the stadium outside. So those are the initiatives we're doing, and I hope that will fascinate you, Bevan.
You heard it, unlimited bandwidth. I remember crashing PTC's capacity about 10 years ago, so let's find out.
So as you can see, over the last hour, we covered a bunch of topics about what's happening, the importance of connectivity, the importance of having a generation of people that are going to come in, that are going to be trained, the fact that we have some upcoming events that should be an awful lot of fun. So what I wanted to do to wrap the session up is I'm going to ask the panelists if they think about the future, the near future. Give me 2 words, 1 or 2 words, that you think are critical, important, that you associated with what we've just discussed. So who goes first?
Well, I'll come in because there'll be less to choose from if you go first, is my thinking on that. So I think the critical thing is flexibility and adaptability, because everything that we think we know about the next 10 years, you can be sure that it's not going to be right. And as an industry, we've got to be able to support whatever the economies of the world demand of us and the people of the world demand. So being adaptable and flexible and ensuring we can take best advantage of this incredible era that we're in is what I take away from this.
Thank you. Paul?
Yes, so I'll continue. So for us, as a supplier, it means supporting the growth. So that's something, and basically deliver faster, cheaper, as the customers want. But anyway, especially deliver dependable networks at a faster pace than ever before.
I think the word of the next 12 months to the next 5 years is going to be change. It is all about disruption and change, and I think that the outcomes out of what's going to happen in the next 3 to 5 years, who is going to survive and who's going to thrive depends on the fastest way to change and adapt, and that's going to be the cornerstone of our industry in the next few years.
hyperscaled, software-defined, interconnected.
That's three things.
Very close.
For me, most probably automation is one, and economies of scale. Maybe one other thing that I'm interested is to see who will be the next hyperscalers, who will be positioned together with the Googles and the likes, and even with like Alibaba's and the likes, and how we can get them to not be very arrogant, but very friendly.
For me, partnership is a key, I believe. I'm not sure somebody also knows the MWC. MWC is the Mobile World Congress, completely opposite side of the sub-optic or PTC. And MWC will be held next month in Barcelona. I also joined this MWC. When you visit to the MWC, it's a little bit different from the PTC. Why? Because not only just the operator or supplier, but also many of the other industry also comes, like construction companies, car industry, game industry, or any other application, education. Many of the industries also join. So I think for future, either this PTC industry, sub-optic industry, I believe we have to invite completely other industries people. Then it becomes, this submarine industry becomes more large. This is my future's dream. Thanks.
Well, thank you very much. With that said, if you could please join me in thanking the panelists for a great session. So I think we have a short break, and then thereafter we're going to be heading out to the telegeography session. Good afternoon, everybody. Thank you.
Okay.